Hello, everybody. I'm back to talk about my lesson plan. Um, as on as I'm planning on going into physics, I had a very interesting challenge with this one. So let's get into it. I decided to talk about the physics of contraception. This would be aimed towards grades 9 through 12, and the lesson length should be about one class or one period, so 40 to 50 minutes. And the standards that I found right here from the NGSS Physical Science Standards, grades 9 through 12, and the Health Education Content Standards for California Public Schools. The learning objectives I have for this are that students will be able to understand how contraceptives work by either creating a potential barrier or through the process of diffusion, and materials with higher tensile strength, lower permeability, and better elasticity make safer barriers, and sort of connected to the construction of materials used for condoms. And the materials I would need are quite a bit, but it should be pretty simple. So for my lesson plan, I would start off with a very simple warm up. It's just sort of to uh, prompt them to start thinking a little bit, right? So I would start off by asking them, well, I would start off by telling them that physics is everywhere, right? Even in health. Uh, in what ways do you think contraceptives might rely on physics? And I would encourage them to brainstorm, talk amongst themselves, and hopefully they come up with things like barriers, motion, energy, materials, diffusion, that sort of thing. And then I would go into sort of just a mini lecture, uh, talking about the sorts of physics concepts in each contraceptive. So for the barrier methods, we have things like the tensile strength of the condom materials, right? Or the elastic potential energy that we can get from them, their elasticity, and like the fracture limits. So at what point do they actually start to break? Very important to know. And we can compare them too, because I plan on getting the condoms there's like several different types of materials. So for the hormonal methods, like the IUDs, shots, patches, those sorts of things, I would relate them to diffusion and how they tie back into the second law of thermodynamics, which states that the entropy or sort of like chaos of a system not in equilibrium will tend to increase, approaching a maximum value at equilibrium. And then, because it's very important to know, I would go back and talk about the the efficacy of each of the different contraceptives. I would have like a slide to present to them, sort of like I had for you guys. So that way they know. And then we'd get into a hands-on activity where they are able to experiment with the different types of condom materials. I believe I'm labeled them up here. Yes, like latex, polyurethane, polyisoprene, and nitrile. Uh, I decided a wide variety because those are the most common condom materials, right? And I would like them to be able to see and measure uh, what their max stretching limit is and why we choose the materials that we do, like latex. It stretches a very good amount and it's relatively cost effective, right? Then we could do a pressure test, fill the balloons or the condoms with water until they burst, and discuss safe pressure ranges for them, and then get into the diffusion simulations for the hormonal contraceptives. Uh, we would place drops of food dye into beakers of warm and cold water to see how the different temperatures can interact and affect the rate of diffusion. And then another one I could have is filling a bag of dialysis tubing, which is a permeable tubing. Fill it with a starch solution, like cornstarch, and place it in a beaker of iodine and the iodine is able to seep through the permeable barrier, and um, the starch isn't able to leach out. So in there, they mix and create a very dark solution surrounded by this lighter solution on the outside. We can sort of see why it's important to choose the correct materials, um, and get a better visualization of diffusion. And we could do a quick little discussion afterwards. Why are the barrier methods both contraceptives and STI preventatives, whereas hormonal methods are not? And then how does the diffusion rate of hormones determine how frequently certain birth controls must be taken? And then at the very end, they do a very simple formative assessment, sort of like an exit ticket, explain how physics contributes to contraception. Sorry. And they could answer that in just a few sentences. And yeah, that would be all. Thank you for listening.